All right, so here is our first e-learning video. I know this is kind of crazy, but we're just going to do the best that we can. So the way that this video is going to go is I'm going to do the notes, and then there's some of them I'm going to have you do on your own. So like I'll do one, I might do another one, and then I'll have you do another one on your own by answering the question on the video. This is just to see if you have an idea of what you're doing. It's really just practice for you. It's not for a grade. It's just to practice within the lesson. Okay. I know you don't have your calculators at home. There's tons of different calculator apps. I'm going to try and send out more information about this, but on the Android phones, I've found Graphing Calculator X84. And the same for the Apple phones. If you search Calculator X84, that is a good app that's free that also allows you to do a log base other than 10. So it's very, very similar to our yellow calculators. In fact, if you hit math, if you might remember Math Alpha Math on our calculators, gives you that log base. So here, like Math Alpha Math gives you that log base. On this app, you just hit math, and then you'll see log base, and that allows you to type in a log base other than 10. So I will try to get you more information about that, but just know that there are a lot of calculator apps out there. Texas Instruments is also working on getting a free Chromebook add-on that is the exact TI-84 yellow calculator that we use in class. So just keep an eye out for that. I'll hopefully get that information to you soon. All right, so for our notes today, this will be a review for some of you because some of my classes have gotten to this lesson, some of you have not. So if you've already done it, it'll be a good review. If you haven't done it yet, then this will be new to you. But for everyone, as a reminder, the number E is about 2.71828. The commonly used logarithm, or a commonly used logarithm, is the natural log, and we've all seen that. That's ln. We've even graphed them and stuff, but ln is just log with base e. So you can see here, the natural log is just log base e. That's all it is. You could even type it in your calculator as log base e, or you can just use the ln button. So you can type these in your calculator. I want you to do this on your own. Type these into your calculator with the ln button, so ln4, and then round to the nearest 4 decimal places. That's important. Make sure you round to the nearest 4 decimal places. All right, moving on. And what's nice about these videos, if you get lost, you can pause it, you can rewind it, you can watch it as many times as you need to. So take advantage of that. If I start going too fast, just pause it, kind of get caught back up, do whatever you need to do to make sure you're understanding, okay? Example A here, it says write equivalent expressions. So what I mean by that is if it's written as a log, I want to write it as an exponential. If it's an exponential, I want to write it as a log. So this first one here is log base e, right? So you might write a little e right there. That was not a good e. So write a little e. So if I wanted to write this as an exponential, remember we do the base of the log raised to the power of the right side, so 0.6931 equals x. And that is the exponential equivalent. So e to the 0.6931 equals x. And you can type that in your calculator. We technically just solved the equation by doing that because now x is by itself. Okay, on the next one, the base of the log remains the base of the exponential. So this would be log base e of, but then the 5 will go in the parentheses equals x. So if we were to write this as an exponent, to go back to where we just came from, it would be e to the x power equals 5. Now, you probably won't see this in a textbook. You're always going to see log base e as the natural log. So you'd most likely just see this as natural log of 5 equals x. And once again, you've basically just solved that equation because now x is no longer in the exponent, x is by itself. And you could type that in your calculator. Natural log of 5 is about 1.6094. That is what x equals. So just remember, log of a number is just a number. And then a quick little review of our special properties. Long story short, anytime you see an E and an ln next to each other, they basically cancel out. They undo each other, and you're just left with, in this case, that's 7. So in this case, our answer is 7. And you could even type this in your calculator to see that. So if you did e to the natural log of 7, you get 7, because natural log is log base e. Those are inverses of each other. They cancel each other out. And same thing over here, natural log of e to a power. So either way that you see it, e to a natural log or natural log of e, those numbers are those are gonna cancel out, and you're just left with, in this case, 4x plus 3. So these are the special properties that we'll use quite a bit. So that's the example for A, and this is the one for B. All right, so now we're just going to solve a few equations. This first part's going to be review, the front page. The rest of the front page is going to be a total review, actually, for everyone. We've done this a couple classes ago. It's the way that we solve an exponential equation when we can write both sides as the same base. So, for example, this really easy one right here, 2 to the x equals 2 to the 8. Well, the whole point of an equal sign is that the left side is exactly the same as the right side. So if both of them have a base of 2, then that means in order for this equation to be true, then x needs to be 8. So we set the exponents equal to each other, and therefore x equals 8, aka 2 to the 8th equals 2 to the 8th. It makes sense. They have to be the exact same. And if the 2's are the same, the 8's have to be the same. Okay, so then what we did on our notes from before, we did number 1 previously, and what we had to do is if it wasn't written with the same base, we had to write it with the same base. So if I have 2 to the x plus 4 equals 2 to the, so what you have to figure out is how do you write 64 with a base of 2? And it's actually 2 to the 6th power. And if you need to check and guess on that, you can. But 2 to the 6th power is 64. Those are the exact same thing. So now that the bases are the same, so we have a base of 2 here and a base of 2 here, all we do is we set the exponents equal to each other. And this one's pretty obvious. You can probably see that x is going to be 2, but if we set x plus 4 equal to 6 and we do our good old algebra 1, we subtract 4 over, you can see that x would need to be 2 here. So 2 plus 4 is 6, therefore 2 to the 6th is on both sides. Okay, the reason I put example 2 on here is just to show you that E is just a number. We know that, we talked about that at the beginning of the lesson. E is just a number, it's used in finance. So this is no different than 2 to the x minus 6 equals 2 to the x squared minus 4x minus 12. So this one, the bases are already the same. So we have E and E on both sides. So, therefore, we can go straight to setting this exponent equal to this exponent. That gives us x minus 6 equals x squared minus 4x minus 12. And basically what we have now is we have a quadratic. So the way that we solve a quadratic is we get everything to one side. We get it set equal to 0. So I'm going to subtract that x over. That gives us negative 5x's. And I'm going to add this 6 to the right. That gives us negative 6. And now we're equal to 0. And the way we solve a quadratic is we factor it and set those factors equal to 0. So we now factor it. We try to find the numbers of negative 6 that add up to negative 5, which in this case would be negative 6 plus 1. So therefore, my answers are 6 and negative 1. We got 2 answers. And if you wanted to, you could check those. The way that I check my answers is I just type it in my calculator. And once again, you can use your calculator app. It should be able to do this. I'm going to, oh, sorry, that should be negative 1. Didn't write negative 1. There we go. I'm going to try the negative 1 first, just to see if that works. So if I type in the left side, I do e to the, and we said x is -1, so -1 minus 6. That's the left side, and you can just leave that decimal in there. Remember that -4 is times 10 to the -4th, so that just means move the decimal 4 spots to the left. And then on the right side, we have e to the, now we have a negative number being squared. You need to make sure you put that in parentheses, minus 4 times, once again, we plug in -1 for x, minus 12. And you can see the left side is the exact same as the right side, therefore the answer is good. You could do the same thing with x equals 6. You'll see that they both work. We will have some extraneous solutions. Again, in this case, we don't have any extraneous solutions when we have exponential equations, but we will have extraneous solutions when it comes to our log equations, so we'll need to watch out for that. All right, I'm going to do number 3 with you, and then I'm going to have you do number 4 on your own. So on number 3, it's one of those scenarios where you have to write both of them to a lower base, because you can't write 27 as 9 to a power or vice versa. So what I'm going to have to do here, I can see that both of these could have a common base of 3. So I know that 3 cubed is 27. But this x is already up here in the exponent. So I got to put that x up there. And then equals 9 is just 3 squared. But don't forget, we already have 2x minus 1 up in the exponent. So if that 2 is going to come up there and join the 2x minus 1, we're going to have to multiply these together. So on the right side, this exponent just comes out to 3x. 3 times x would just be 3x. Equals, and then on the right side, 2 times 2x minus 1, we need to distribute the 2 through there. So that would give us 4x minus 2. So that comes out to 4x minus 2. And then from here, you can just solve for x like you would in Algebra 1. So I'm going to subtract the 3x to the right. And that gives us x equals, and then if I add the 2 to the left, that gives us x equals positive 2. That way we avoid anything from being negative. X equals 2. All right, to go ahead and do example 4 on your own. Once again, this is not worth a grade. The number 4 is a bit of a challenge. I'll give you a hint here. 25 is 5 squared, right? So 25 is 5 squared. And then 125 is 5 cubed, right? But it's on the bottom of a fraction. So remember, we have to make that exponent negative. So 1 over 125 is 5 to the negative 3rd power. See if you can finish solving that for x. All right, and the last one I'm going to do on this side of the page is number 5. So this exponential has a little bit more going on. So far we've just had like one thing on each side, but now we have like this +1 going on, this ×2 going on. So it's kind of going to be like all of the other solving that we've done this year, like absolute value and square roots and so on. So this here is our exponential. 3 to the x plus 3. That is the exponential part of this equation. So just like all of our other solving, we need to get that by itself. Just like if it was an absolute value or a square root, we always want to get the part of the equation that has an x in it by itself. So I would first subtract 1 over. So that would give me 18. Now the part that people forget is this 2 in front. We need to divide that 2 away. So if we divide that 2 away, we get 3 to the x plus 3 equals 9. And now we're basically back to square one. If you can write it with 3 on both sides, do so. And once again, we can, right? 9 is just 3 squared. And on our next lesson, we'll actually learn what to do if you cannot write both sides as the same base. But we can now. So 9 is 3 squared. So therefore, once we get the bases the same, x plus 3 equals 2. Subtract that 3 over, and that means x equals -1. All right, I'm going to skip example 6, and I'm going to go to the backside now, example 7, and you'll notice these are very similar. So if the front side made good sense to you, this should be very easy. It's just the logarithm version of what we just did. So if we have one log on both sides, remember the whole point of an equal sign is that the left side is exactly the same as the right side. So that must mean that m is equal to n. Or a really easy version of this, if we have log base 4 of 2 equals log base 4 of x, well, it's pretty obvious to see that x must be 2 in order for both sides to be log base 4 of 2. Okay, so let's look at example 7. We have one log on both sides. So therefore, we set what's being logged equal to each other. So this is very easy. Just get a little algebra 1 equation here. If I subtract my 2x's over to the right, just to avoid going negative, we get 1x. And then if I subtract this 1 to the left, we get x equals 3 minus 1 is 2. So then you can see if you plug this back in for x, over here we'd have 2 times 2, because x is 2. 2 times 2 would be 4, plus 3 is 7. So we get log of 7. And then on the right side, 3 times 2 is 6, plus 1 is once again 7. So you can see the left side is the same as the right side. Log of 7 equals log of 7. That is the value of x that creates the same log on both sides. Okay, example 8. I'm going to do example 8. Actually, you know what? I think I'm going to have you do this one on your own. This one's pretty easy. It's pretty similar to example 7. Okay, so go ahead and do this one on your own. Natural log of x squared minus 2 equals natural log of 14. Once again, not for a grade, just do your best and then submit your answer. All right, and the last part of our notes for today, it says sometimes you will need to condense logarithms first so that there is only one log on each side. So let's take a look at example 9. So the way that we condense logs, if there is a number out front, that becomes the exponent of what's being logged. So I could write this as log base 5 of x cubed, and then minus log base 5 of 4 equals log base 5 of 16. Okay, and then we have 2 logs on. We still have 2 logs on the left and 1 log on the right. In order for that little trick to work that we just did on numbers 7 and number 8, there has to be 1 log on both sides. So once again, we have another property that tells us we can condense 2 logs that are subtracted by dividing what's being logged. So this becomes 1 log base 5 of x cubed, x cubed divided by 4 equals log base 5 of 16. So we condense that left side so that it's really easy to compare to the left side to the right side. So we now have log base 5 of x cubed over 4 equals log base 5 of 16. We have 1 log on both sides. Sorry, it's supposed to be a highlighter. We have 1 log on both sides. Therefore, this must be equal to this. So we go x cubed over 4 equals 16. To get x cubed by itself, we would multiply both sides by 4. That would give us x cubed equals 64. And then we cube root both sides. Therefore, x equals 4. And just to practice plugging that in, I'm going to type this into the calculator just to see if it works. So follow along with me here. We got x is 4. So if I type in 3, and then mine is math alpha math, but on your app you should just be able to push math and then log base, so log base 5. And we found out that x is 4 minus log base 5 of 4. And that's the left side, so I can turn that into a decimal. And then the right side is just the original equation is log base 5 of 16. We can see that's the exact same decimal, therefore the left side equals the right side. X equals 4 is the correct answer. All right, take a moment and do I'll do number 10 with you, and then I'm going to have you do 11 on your own. How about that? So let's look at number 10. Example 10, it says natural log of x plus natural log of x minus 6 equals natural log of 7. So once again, I need to condense these. And the way we condense them is by multiplying in this case, because the two natural logs are added together. So this becomes x times x minus 6 equals natural log of 7. Okay, and then for the x times x minus 6, we need to distribute that through. So this becomes natural log of x squared minus 6x equals natural log of 7. You kind of get the hang of this now. We now have one log on both sides, so therefore what's being logged must be equal. So we get x squared minus 6x equals 7. And we now have a quadratic. So I'm going kind of fast here just because this is solving quadratics. We've done this all year long. So we factor. The factors of -7 that add up to -6 are -7 plus 1. So my answers are 7 and -1. Okay, now I did warn you on the front page, with logarithms, we can have extraneous solutions. So let's check -1. We know that those negative numbers can be weird sometimes. So if I type in the left side of this equation with -1 for x, you can use the natural log button of -1 plus the natural log of -1 minus 6. You can see that gives you this crazy number, and it has an I at the end of it. More closely, even if I just type in natural log of -1, it's imaginary. You cannot take the log of a negative number. And if you think back to, so I'll talk about that. So long story short, -1 is extraneous. It doesn't work. Now you can plug in 7 and it will work. So we only have one solution here. But let me real quickly talk about why this is extraneous. So natural log of a negative number, say -1. Really what that is e, and then remember, like what we did at the very beginning of this lesson, that's e to some exponent equals -1, right? If I take the base of the log and raise it to the right side, that equals the number in the middle. We've been doing that for weeks now, okay? Now, e is a positive number. Is it possible to take a positive number and raise it to a power and get a negative answer? So for example, e is just a number. So e to a positive number to a power, that's not possible to get a negative. We know even a negative exponent, so if I did e to like the negative first power, that just makes it smaller. We know that a negative exponent moves the number to the bottom of the fraction. That makes it even smaller. So it's not possible to raise a positive number to any power and get a negative answer. And therefore, you cannot take the natural log of a negative number because that's basically what you're asking. So if at any point you get an answer and you can see that at some point in the original equation you take the natural log of a negative, then that is extraneous. So for example, I'm going to have you do example 11 on your own, but if you take a look here, we have the log of x. So therefore, if x comes out to be negative, let's say if x is -4 or -5, whatever it may be, that would be an extraneous solution. You cannot take the log of a negative number. All right, to go ahead and do 11 on your own, submit your answer, and that is all for our first video.